So if I think about what's going on in this problem, what I can see is that for the addition, I have one box in the first row, plus two boxes in the second row, plus three boxes in the third row, plus four boxes in the fourth row that are colored in, which gives me a total of 10. So I've got 1 plus 2 plus 3 plus 4. Now, if I think about multiplication, and my suggestion there was to think about the large rectangle and how much of the rectangle is shaded in. Well, if I look, it's a 4 by 5 rectangle, right? And I say, well, how much of it's shaded in? And you can look and say that, oh, half of this rectangle is shaded in. If I look here, I can see that it is the exact same piece if I reflect it. So I can say that that's half of my rectangle. Well, what size is my rectangle? It's 4 rows by 5 columns. And if I think about, well, how much is that? Well, half of 4 is 2, and 2 times 5 is 10. So I can either say 1 from the first row plus 2 from the second row plus 3 plus the third row plus 4 from the fourth row, or I could say 1/2 times the rectangle, which is a 4 by 5 rectangle. Let's look at the next one then. So part 2 said, well, let's expand this. And now let's look at it as if it was a 5 rows and 6 columns. So here I've got the same setup. It's 1 plus 2 plus 3 plus 4. And then now I have plus 5. If I add those numbers up, I get that there's 15 blocks shaded in. Now, if I think about the entire image as to what's going on, I would see that again, I have half of my rectangle shaded in. So I could say that that's half of the entire rectangle. Well, what's the size of this rectangle? It is 5 rows by 6 columns. And I can multiply those numbers. 5 times 6 is 30, and half of 30 is 15. Now, let's look a little deeper at comparing these two things. What we notice is in both of these images, look at the sums. I'm summing consecutive numbers starting at 1. 1 plus 2 plus 3 plus 4. Or 1 plus 2 plus 3 plus 4 plus 5. I'm adding up those consecutive numbers as I'm going along. So, and it's creating this pattern that at the same time, while I'm adding the consecutive numbers starting at 1, my multiplication is able to say, well, if I think about that being a rectangle, where that last number represents the number of rows, and then my number of columns is always one more. So I had 4 rows, 4 plus 1 gave me 5 columns. 5 rows, 5 plus 1 gave me 6 columns. So if I think about the fact that I have 8 rows by 9 columns, well, the 8 is what I'm basing everything off of. In addition, I would be adding all of my numbers, in this case, to 8. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. In multiplication, I'd be saying, oh, that means that I'm going to do 1/2 the number of rows I have times the number of columns I have. And in both cases, I will end up with the fact that 36 blocks would be colored in. Now, as my numbers get larger in this sum, I start to see, well, which is easier to actually solve? And I can start to say, oh, adding up all these numbers becomes more and more complex the longer the string comes. So maybe I want to start to recognize, how do I use this multiplication? So let's look at the fist bump example and understand, well, how does this become so much more crazy? So in this one, I have 20 students. So that's important to remember. I've got 20 students. They all want to fist bump together. So I want to know if I'll create an expression that says exactly how many fist bumps will I need to give. Now, if I think about it, and it's that my hint was to start with how many fist bumps will student 1 give. Well, if student 1's going to give a fist bump to every other student, and there's 20 total students, well, is he going to give a fist bump to himself No. That means the very first student gives 19 fist bumps. Now when we go to student 2, well, student 2, he's not going to give a fist bump to himself, so he's down to 19, but he already gave a fist bump to the first student, so he's down to only 18. And now think about student 3. Student 3 won't give it to herself, won't give it to student 1, and won't give it to student 2, so now student 3 is down to 17. And I can keep going down the line until I'm adding up the numbers to where I get to the last student. The last student will have no one to fist bump. Now, if I add all of those numbers together, what I'll end up with is 190. So I had to add 19 numbers together and I get to 190. Now let's think about the corresponding multiplication expression. Now, it doesn't come quickly often because when we looked at our expressions before, because it says to think about what you've done previously. Well, previously, like say we go back and compare, we said that 1 plus 2 plus 3 plus 4 plus 5. I know that here my final row number told me to do 1/2 the row times the row plus 1. That's why I did 5 times 6. But here, my numbers aren't in the same order. Or are they? While it may be going 19, 18, 17, 16, and they're going in reverse order, remember that addition is commutative. So what I really have here is the sum from 1 all the way up, and I'm just going to do dot, 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 plus 16, plus 17, plus 18, plus 19. I'm adding all the numbers from 1 to 19. So if we think back to our rectangle problem, 19 becomes the row number, which means that if we want to do multiplication, we could do 1/2 of our row number, and then our columns is just one more, in this case 20. And half of 19 times 20, well, half of, because that's commutative, I can multiply and divide that however I want, and I could recognize 20 divided by 2 is 10, and 10 times 19 is 190. Even such, if I use my calculator, multiplying those three values is much faster and easier than trying to add all 19 numbers. So that leads me to my final problem, where if I get to 100 students, I don't want to sit here and have to go and say that I've got all these numbers from 1 to 100 that I have to add. It's much easier to say, oh, that last number is my number of rows. If I made a big rectangle of this to show the same thing, and I know that it was 1/2 of that rectangle, where my last number represented my number of rows, and I know my number of columns was always one more. And that will be much easier to solve than trying to add up all of those 100 numbers. And this would leave me with 5,050. I'm not sure I wouldn't want to try to add up 100 numbers together to make sure I end up at that same value when I could multiply much, much quicker.